here we've got an example where we've got ourselves a triangle and there's no right angle, so we can't use our regular right angle trig. We've got to use something a bit more complex. If we look at it, we've got a side length here, and an angle in between them. So we couldn't use the sine rule for that, as it happens, but we could use the cosine rule. What I'm going to do is I'm just going to label my triangles. So just remembering that we label things with the letter of the angle that's opposite them, right? So we've got A, B, and C, and we want to find side length A, this little a here. Now, as it happens, this is written in the exact way that our cosine rule is. The way I remember it is, so it's kind of like Pythag. So it's a squared equals b squared plus c squared, but it's not quite Pythag because it isn't a right angle triangle. So you kind of have to fix it up with this last term, where we do take away 2 times the 2 other side lengths and cosine of the angle. Yeah. So yeah, that's how I remember it. Now it's just a matter of subbing things in. So a squared is going to be 7 squared plus 3 squared. Take away 2 times, we got 7 times 3 times cos of 35 degrees. All right, so what we've got 49 plus 9, take 2 times 3 is 6 times 7, what are we going to get? Is 42 cos of 35. Now from here, I'm going to put this into a calculator because it's getting a bit messy. For example, it's got a cos of 35 degrees in there. So I'll get up my calculator and bring it over here. So go add calculator. Got so a squared is 49 plus 9. Take 42 cos of 35. Because I'm in radians mode, I'm just going to put in a little degree sign using the thing next to pi. And it's not going to be a nice number, so I'm going to do control equals to get a decimal. Now, that was a squared, right? That was what a squared equals. So I'm going to need to have the square root of my answer up here. And there we go. I get 4 point, so what a here is 4.86 centimeters. And if I go back to my example, that looks about right. I mean, it's looks bigger than this line, smaller than this one, 4.86, that fits the bill. So we're happy with that. And let's check, same as what I got the last time I did this. So we can get rid of that. Let's have a look at another one. So this one isn't written in terms of A, B, and C. So we've just got to use our cosine rule a bit kind of cleverly, just replacing things in their appropriate place. Yeah. So what I might do, so what do I need to get? I need to get the size of the angle R. This one in here. Now I find it easier to remember the cosine rule in that way that I wrote in the last one, even though if you wrote it in the other way, it's probably easier. I'm going to do it the original way. So if I think about it, R squared is p squared, little p squared plus little q squared, take away 2pq cos of R, right? So cos of R must be R squared, then take these ones away, yeah? Take p squared, take q squared, all over this coefficient, so negative 2pq. And then probably want to get rid of that negative on the bottom, so we just times everything through by -1. That should do it. So yeah, p squared plus q squared, take away r squared. We're just really swapping the signs and writing it in a nice way, and we get 2pq on the bottom. So that's cos of r is all of that. So let's so r then, right, would be inverse cos, just getting rid of that cos of, so what? Let's label everything. We got p here, we got q here, and we got, nope, r here, and q here. Let's just rewrite that. So what do we got? P was 4.2, we need 4.2 squared plus 6.9 squared, take away 4 squared, all over 2 times 4.2 times 6.9. And now again, we're going to need to use the calculator because we can't do inverse cos in our head. So let's do it all in one step. Let's see how it goes. Oh, not happy with me. So inverse cos, we get that just from the trig menu. Let's get a fraction going. 4.2 squared, 0.9 squared, take away 4 squared, all over 2 times 4.2 times 6.9. Now if I just press enter, oh, it's done it for me because I'm in auto mode and I've got decimals, so that's great. So the angle in radians is 0.555335. I'm going to convert that to degrees just because I got a better handle on what degrees give me. So I'm going to times it by 180, divide by pi, and I get 31.8 degrees. So this is equal to 31.8 degrees. And let's go back to our slides here. If I look at that, does that look about 31.8 degrees? Sure, looks about 30 degrees. Let's see, same as what I got the last time. Very good. So let's just get rid of all that mess. And there it is, written out nicely for you.